All right, so guys, once again, we are going to be looking at some trigonometry. And for this topic in particular, we are going to be looking at the applications of trigonometry. We have seen where the trigonometric ratios that we have been using so far, these are applicable to right angle triangle. And so we are going to be looking at situations, real world problems, are real world scenarios where we may encounter right angle triangle situations, and we can apply what we know from trigonometry to those questions. All right. So we're mainly going to be focusing on how we can apply what we learned so far from the trigonometric ratios. All right. All right. So the first thing that we're going to be looking at is angle of elevation. Now, remember now, whatever we're doing is more applicable to real world. So when you think of the word elevation, what comes to your mind? Anybody?
So like when you're going up.
Okay, all right. So correct, because we know we know what we call an elevator. It's a machine for lifting, and generally when you're elevated, that means you're getting higher or you lift upwards. So when we are now referring to angle of elevation, we are really thinking about an angle relating to some height above the ground. Is that clear, guys? So I'm going to put a definition here. So here we say that if you look upwards at an object, the angle formed between the horizontal line of sight is called the angle of elevation. So here we have a new word again, line of sight. Can anybody clarify what we mean when we say line of sight? Nobody have any idea what we mean by line of sight?
The side we're focusing on, sir.
Say that again, Ms. Milson. Could you repeat that for me, Miss?
Are you hearing me, sir?
Yeah, I'm hearing you now.
I'm saying, would it be this side that we're focusing on?
All right, so we're in
when
this
referring to the line of sight.
In this case, we know we are referring to some real world context of right angle triangle. But I don't want you to think of the side in relation to the triangle yet. I'm just thinking about the word line of sight. Now, when you think about your sight, you're thinking about you looking at something, and just imagine that straight line in which you're looking is what is referred to as a line of sight. So if you imagine that you're focusing on some object some distance away, the line from your eye to the object would refer to as your line of sight. Is that clear to everyone? Raise your hand if that is clear to you guys. All right, so we say that the angle of elevation is the angle formed between a horizontal line. Now here we have a horizontal line. Can anybody remind me what an horizontal line is?
A line that goes from left to right or right to left.
All right, so a line that goes across from left to right, as Mr. Lamar would have said. So it would be a level line going right across. That's what we refer to as a horizontal line. Now, if you look back at the definition now, so if we're looking at the angle of elevation, and remember an angle is a measurement between two lines joined at a point. So if the angle formed between the horizontal line and the line of sight, it means that the horizontal line and line of sight would join together at a point to form the angle of elevation. As we know that the angle is a measure of how wide the opening is between the two lines at the point where they are joined. All right, so just to give you an idea, so here we have a diagram illustrating just what we are saying. Now we have the eyes above the ground, referring to that line, this line that we go, this red line, the shorter red line with the arrow points from the ground level. So we are thinking of that line as the height of a person. And let's say that to the top of that line is to the person's eye. All right, so the horizontal line also comes from the eye level right across from left to right. So what we have left to do now is to put in our line of sight. Now the object that we are looking at above the ground would be at the letter A. So at the point A, that would be the height of the object above the ground. So our line of sight would be this line looking from the eye level up to the point A, all right? And then now we know that our angle now would be the angle formed between the line of sight and the horizontal line, and that is the line, that is the angle that we refer to as the angle of elevation. And that angle only forms when the line of sight is going upwards. Is that clear to everyone? Raise your hand. All right, here we can clearly see now how this diagram would relate to a right angle triangle, because we're assuming that the object above the ground is on a vertical line from the ground to the top of, or to the point where the object is. So from the ground to A, we're considering that to be a vertical line. Now that vertical line could represent some real world object, like it could be a tree. So that we could have a vertical tree, and at the top of the tree, we have some object A. You could be standing some distance away from the tree, which would be the length of the horizontal line from the tree to your line of sight. And then now, from that distance, you are looking up at A at the top of the tree. And so the line of sight would be from your eyes to the top of the tree. And what you would understand about the line of sight, it would be an imaginary line. It would not be a real line that is there, because actually you are just imagining that you're looking through a straight line from your eye to the top of the tree where the object is and looking at the object. So generally your line of sight would be an imaginary line. But what we can do, we can somewhat use some device to measure that angle. And if you are ever close to any construction site, or ever been anywhere where they are surveying property, you'll see they have this tripod stand with a little thing at the top, like you'd call it something looking like a telescope that you're looking through to look at some distance away. That instrument is known as a theodolite. and it has an eyepiece like a telescope that you look through. But when you use that eyepiece, you can actually measure the angle from the horizontal line when you're looking through that eyepiece. So that would give you the angle of elevation depending on what you're looking at through that theodolite. Is that clear to everyone? All right, so with all of that said, let us now look at the angle of depression. So if elevation is when you're up, can somebody tell me what happened with depression? So if you're looking at an object above ground, at some height above the ground, your line of sight and the horizontal line will form an angle known as the angle of elevation. So can somebody now tell me what you think would form, what lines would we use to form the angle of depression? Can anybody tell me what depression, when you hear the word depression, what comes to your mind?
Breaking down.
All right, so depression is actually down. And so we use it to refer to also when we are down in our spirits or in our, when we are emotionally challenged, then we say that we are down. So depression in every sense, we are referring to down. But when we're referring now to angle of depression, you know, in order to form an angle, we need two lines. And if we are looking down through our line of sight is looking down, then we have to have a horizontal line with the line of sight that we use to measure the angle of depression. All right, so if you look downwards at an object, and this could be in the case of where you're on a cliff and you're looking down in the ocean, or you may be on the top of a building and you're looking down on the city or something of that sense. So the angle formed between the horizontal line and your line of sight, right, is called the angle of depression. And that is when you are looking down, guys. All right, so our diagram would look something like this. Now that would be a horizontal line. Now that line, diagonal line going down would be your line of sight. And from the top down to the depth there, that would be the height or the depth of below the horizontal line. And if you can imagine that the line of sight is coming from somebody standing on the top of the cliff, so that height above the cliff would start from here up to here. So this would actually be a person looking down. And so that would be the line of sight. Is that clear, guys?
So can you please go over?
All right, so I was saying now, your angle of depression is the angle formed with the horizontal line. Now, clearly, you would know what the horizontal line is, because the horizontal line is the line that going right across. That's the horizontal line, that straight line going across. Now, your line of sight, you're looking down in the ocean at an object. So this is the line through which you're looking at the object A. So the object A would be like in water. You're on the cliff, and down here is water, and there's an object in the water down there. that we are looking at. Is that clear now? So the angle that is formed with the horizontal line and your line of sight, that angle is referred to the angle of depression. And so it is important to always remember that is the angle formed with the horizontal line to your line of sight. So the horizontal line has to start from your eyes, and the line of sight has to start from your eyes, and the angle between those two lines will be referred to as the angle of depression. All right, any question, guys? Everybody is clear with that? Now, clearly we can see also that we could form a right angle triangle if we are standing on a cliff looking down through our line of sight and a horizontal line. Now, one of the usefulness of trigonometry is that you can apply one of the trig ratio to help us with questions like these. Now, one of the things that we know, as I mentioned before, our line of sight would be an imaginary line. And because it's an imaginary line, it would be difficult for us to actually measure your line of sight. And if you notice in both cases, the angle of elevation and angle of depression, your line of sight would actually form the hypotenuse of the right angle triangle. So the line of sight is an imaginary line, and it is impossible to actually stretch a tape from your eye to the object through the line of sight. Because imagine you're standing on a cliff, you cannot use a measuring tape from your eye. You would have to be able to fly like a bird because the line of sight is going through air. Is that clear to everybody? So because the line of sight is somewhat impossible to measure in most scenarios that dealing with angle of elevation and depression, then which of the trig ratio you think would be suited if we are working with this triangle? Which of the trig ratio, if we are unable to measure our hypotenuse, that means we can never have a value for that. We don't have a way of measuring it. Then which trig ratio would be best suited when we are working with the angle of elevation and the angle of depression? Anybody? Ms. Waysome, do you want to shine some light on it for us?
No, sir.
Mr. Lamar?
Yes, sir. Can you repeat?
Yes. Can you give us an answer to my question? I was asking which trigonometric ratio would be best suited for angle of elevation and depression, given that we are unable to measure the line of sight because it's an imaginary line through air and we can't really measure that unless we have wings.
The tangent.
All right, so we would be able to then apply the tangent. Why would we be able to apply the tangent, Mr. Lamar?
So you said we won't be able to use the line of sight, and line of sight is the hypotenuse, and the tangent ratio is the only one that does not use the hypotenuse.
Right. So
finding an answer.
Apart from that, what else would enable us to be able to use the tangent ratio?
Sir, we would have the horizontal line and the vertical line.
Right.
Which would be adjacent on the opposite side. And we would not have the hypotenuse, which is the line of sight.
Right. So what it would mean then, we are generally able to find the vertical line and the horizontal. And in this case of the cliff, we know that we could probably measure from the depth of the water to the top of the cliff up to the
Yes,
line
sir.
to the eye. And maybe we can also go in the water to measure the distance where the object is from the foot of the cliff. All right, so for that reason, the tangent ratio is often most applicable when it comes down to angle of elevation and depression. So not saying that there won't be any scenario where you could apply the other two ratios, but when you think about angle of elevation and depression, just think about the tangent ratio. Is that clear, guys? All
Yes,
right.
sir.
So with that said, then let us move on to see how we can apply what we know. So here we have our first example on elevation. Now, oftentimes the elevation and depression questions, they generally come in a worded form. There may be some instances where you may actually get a diagram and they might put in some of the information based on the diagram. But in general, you should be able to read the question, and from the question, you should be able to construct a diagram, and then with the diagram, you should be able to make some calculation based on what you're asked to find. All right, so what I want you to do, I'm going to give you about 3 minutes to read through this question. And then I'm going to ask, after you finish reading the question, I'm going to ask individuals to walk me through constructing a diagram for this, all right? Give me a second, guys. All right, guys. So you can read through the question and be prepared to walk me through constructing a diagram based on the question. And then we can determine what the question is really asking for and how we can go about calculating it. So if there's anybody who has read the question and is ready to walk me through the diagram, you can raise your hand.
Sir?
Okay, are you ready, Mr. Lamar?
Sir says walk through the question.
You are going to help me to construct the diagram. So you're going to tell me what to do in terms of the diagram.
Okay, sir.
So are you ready?
Okay, sir. Yes, sir.
All right, before you start, Mr. Lamar, let me just read through the question for everybody, and then now you can walk me through. All right, it says to find the height of a tower, a surveyor set up his theodolite 100 meters from the base of the tower. He finds that the angle of elevation to the top of the tower is 30 degrees. If the instrument is 1.5, that should be 1.5 meter from the ground. What is the height of the tower? So that's the question. They want to find the height of the tower. So here we know we have the ground level, we have a tower standing tall, we have an instrument, the theodolite, standing tall on the ground. We know that the theodolite is 100 meters away from the tower, and we know that it is measuring an angle of elevation of 30 degrees. So with that said, all right, now, Mr. Lamar, you want to walk me through the process?
Sure. So just draw on ground. Draw on ground.
So draw the ground level then. All right, so let's say that's the ground level. There you go.
So draw one tower.
Draw one, a
Yes, sir,
tower.
just draw one. Oh, yes, sir.
All right. So let's say that this is our tower. Maybe I should utilize the space below some more. So let us go a little down closer to the bottom of the screen. All right, so let's say that this is our tower. It's a vertical tower, meaning that it's going to be at right angle to the ground, all right? So here we go, Mr. Lamar, here's your tower.
Yes, sir. Joy estimated 1.5 meters on Joy theodolite
All right, so where are we going
on
to?
this on the left side.
All right, so on the left, what are we drawing? A vertical or a horizontal? What are we drawing?
Sir, on vertical.
All right, so let's say that this is our theodolite.
Yes, sir.
All right, so it's an instrument, so it has the eyepiece on it. All right, what else now?
Sir, draw your 30 degrees line of sight from the top of the tower to
All right,
from the
so
theodolite.
line of sight from the theodolite to the top of the tower. All right, so we're thinking that the line of sight will be in the instrument, and we are going right to the top of the tower based on line of sight. All right, what else?
So you can draw your horizontal lines
All right, where would I
from
draw?
the top of the tower and construct your triangle.
Where should I draw the horizontal line?
So first draw on horizontal line from me a point but me can't really.
You can describe, man, the top of the
Sir.
theodolite, below the
Sir,
floor.
like illegal part. Yes, sir. From the theodolite, from the top of the theodolite.
All right, so you
Yes,
could
sir. So
draw-
yes, sir.
all right.
Yes, sir. And your vertical line automatically form.
So there's a right angle triangle, right? So the right angle triangle, so we have a right angle here. All right, what else?
So that's all. No, sir. So no one try to find it. Eli Tower.
Yeah, but what do we need to be able to find anything? Don't we need some more information?
Wait a minute, come, sir. We have sure, but we have the degrees. We have the length from the tower. We have the length from the ground.
Tell me where to put what, where to label what.
Oh, sir. So labeling.
Yes.
All right, sir. So you can put 130 degrees. In that, yes, sir.
All right, what else?
Sir, the baseline, you can put 100 meters. No, sir, not that line.
This line, this
Yes, sir,
line.
that line. Yes, sir. Sir, and you can put 1.5 meters at where the
Where?
tail, yeah, that
Yeah.
line is, the vertical line with tail light.
The height of the theodolite.
Yes, sir.
All right, so that would mean from here to here. All right, what else now, Mr. Lamar?
Sir, we're already plugging in all the knowns.
What are we trying to find?
So we're trying to find the length of the height of the tower now, sir.
All right, so how can we, so the height then
Would be equal to the,
would be from here to the ground level. All right, so that's the height that we're trying to find.
yes, sir.